I did the introduction, was showing you some external modeling here, some external flow modeling. Specifically, I was showing you data center. So let me bring that one back in. Some of the features of CoolSim in the new release allow you to do things you couldn't do before. So what I was showing you before I forgot to share is this model. This is just a standard data center model. And I've done hot aisle containment here. And I'm supplying cold air down. This is non-raised floor. So I'm coming down through the cooling unit into the room. Okay, the units are tied to the ceiling automatically. CoolSim does that for you. It has a ceiling plenum return. This is a hot aisle design. What I was showing you about grouping is that you can take a structure and group it. So the way I built this, and let me ungroup it for a moment. The way I built this is with individual components. So I placed a rack in place and each one of these sides to the containment in place. I aligned them. So for those of you who aren't familiar with CoolSim, we have some very nice alignment tools. Like if I put my surface like that, my baffle, I can click these two and then do a close gaps in X. And then I can do a close gaps in Y and align this very nicely. And you'll want your corners to look like that on your baffles, 45-degree corners. And then once you build that structure, you can group it. So here I'm going to use my rubber band. The rubber band is a control key and a left mouse, and you just drag and rubber band it. And when you let go, it gives you this structure. It shows you everything in it. This also allows you to edit if you want, and I can group it. Okay, so there's my group. Now, once I've grouped it, I can clone it. I can Control-C, Control-V it, so I can just copy paste. I can also save it. I can export it. So if I build a structure that I'm interested in, I can either share it into my library, a local library, or I can export it out and write it right out to a directory of any place I want, give it a file name, and it'll write it out as a very small file. It's in kbytes. It's quite small. And then within CoolSim, you can read it back in at some point later. So this grouping is very handy for multiple structures. You can even group everything in the entire room and export it, create a new room and import it back in. I use that sometimes when I'm having trouble with the model and I don't know why. I sometimes build a new room, export all the geometry, read it back into the new room, and try that. That's a method that we've used before for diagnostic. So here I've simply created one and then cloned it. Clone is a very nice tool as well. It sits up here, clone. Clone is effectively a copy with offset. So what clone allows you to do is to take a single copy of it, replicate it with offset. You can replicate it in all three directions. So you can make n copies. So this is a little counter, and you can offset it anywhere you want and replicate it. This is very nice in data centers. There's a lot of symmetry in data centers, at least new ones. The older ones are kind of problematic, of course, but in new ones, it's quite nice. So you can do that, and that's how I built the second one. And then when I ran, I used what we call CPV. So I ran crack parameter variation, CPV right there, crack parameter, under the simulation tab. And I set up 4 variations. This is another beautiful feature of CoolSim. You can do multiple variations at once. So I have crack parameter variation turned on. That means these now control the crack units. And all I did here was a round robin shutting them off. So I went right around 1, 2, 3, 4 and shut them all off in sequence. So run 1 will have crack 0 off, etc., right down the line. Okay. So if we take a look at our output, I ran this prior to the event today. I have 4 runs. This is the summary report. So this is my lower left-hand corner. I have a design tab and a report tab. And in the report tab, I have 4 runs, and this is a summary of what's in the run. And then under each one of the runs is a full set of results. This is the same set of results you would get from CoolSim normally, except now there's 4 of them because I made 4 runs. So you can really do a lot more simulation with CoolSim because you can set these things up and let them run concurrently, as opposed to the traditional method where you'd be setting it up with a set of conditions, running it, setting it up with another set of conditions, running it. This summarizes it all for you, up to 4 at a time. And you know, under each one of these is a complete detail about how the units are performing. So for racks, we've got a report for cracks, etc. And over here is the 3D files on the left. The most important of which is the Ashrae recommended temperature inlet. So this is a 3D plot that we have that shows you conformance to the Ashrae specification for rack inlet temp. So here are the US Fahrenheit spec, 64.4 to 80.6. And in this case, I've built the design. It's an N+1 design, so of course, it's going to pass. It's a fairly modest design. So that's normal. That runs fine, no issue. But we also, in many cases, would like to be able to model an alternative, what I call an emergency case. You know, what if the cooling units failed altogether? What would we do? And there are different strategies, but I'm going to show you one here that's called my emergency case. And it's now made available because we have new features in CoolSim. So let me go to my emergency case if I haven't shut it already and take a look at that one. Looks like I may have shut it already. So in the emergency case, what we're going to do is we're going to bring in air from outside. No, that's not my emergency case. Hang on just a minute. I think it's over here. Nope, looks like I closed it. So let me open that. So I'm going to open another version of CoolSim here and open my emergency case. In emergency cases, what often happens is that you'll want to bring air in from outside if you possibly can. So the model that I set up and will show you here is a case where we went outside and grabbed air. 2 things happened. One is on the hot side, we open louvers in the room and allow the air to escape. And we also, at the same time, opened up inlets on the sides of the walls. So here's my emergency case here. And in this case, we brought in air from adjacent volumes, adjacent rooms, if you will, and used fans. So you're just modeling as a fan, and you're assuming you have a constant temperature coming in. So that's an alternative method. People will do this. They will say, well, look, in a failure mode, we're going to open the doors or something. Now, this is a hypothetical case, and you know, again, it's just showing you the capability of the modeler. So here what I've done is I've added inlets and outlets. This is a new feature of CoolSim 5. The inlet outlet object is right here. You can drag and drop it in. It behaves a lot like a baffle because we use the baffle construct to make this. So if you right mouse it, you can set the orientation. So, you know, plane, you can also set the size, but you can also set the airflow. Here I'm setting it up for, in this case, it's set for 4800 at 60 degrees. You can set it for anything you want. Furthermore, you can adjust the angle of the flow on it. This is a very nice feature. So let me get in a little close here and I'll be able to show you that you can adjust the angle. So here I have normal surface. I can flip that so it flows the other way. So now I've just flipped the flow to go the other direction. So let's bring it back so we can see it a little bit better. So bring it back over here, but I can also specify the angle of this flow. So I can set the angle, I can adjust it to whatever I want. So here's the angle, and this is much, much easier than unit vectors. If any of you have ever done this kind of work, you know they want to use unit vectors, which means you have to figure out trigonometry. We've done it with simple slider bars. They're very handy. You can angle the flow coming out of a diffuser, or an inlet in this case. So now in this case, I'm not interested in angles. I just set it to be perpendicular. I've got two up here that are venting to the atmosphere. So my supposition in this model is that the outlets just go to atmosphere. In this case, they're outlets of the room. They just float and they go to atmosphere. And these are inlets over here. They're letting air in. So the idea is if my cooling units fail, I just bring in air from the outside. This could be an adjacent room, could be fans, could be a lot of things. I'm just using it as an example. And in that case, you can run it, turn the cracks off, and you'll get flow conditions. Now, in this case, it didn't work as well as we'd like. We're getting some hot spots where it was cool before. We're getting some hot spots. And the reason that's true is because we have some issues with air coming in. We've added a couple new plots down here. One of them is inlets by temperature. So here I'm able to show you the inlets coming in. And what I was describing was this feature of CoolSim that is now available. In the upper left-hand corner, I clicked on this little manager, this little view manager. And up there, you see my cursors in the upper left-hand corner. And there is a caret that allows you to turn on and off surfaces. So to make this a little clearer, I'm going to turn off the ceiling and I'm going to turn off the room. This makes the image a little clearer for you to look at. And you can see there that I can see those path lines coming in from those inlets right now and feeding. Now, I've got hotspots over here, and that's because my inlets aren't aligned very well to my geometry. And this will often be the case. They're just not in the right place. So those are inlet path lines. We can also take a look at outlet. That's also very important. Path lines from racks here is the next one. So we're going from the racks to the outside. You see here, this is quite busy, but I've got air going up into the ceiling plenum and exiting the outlet. But it's also going other places. It's wrapping around. And one of the best ways to see this is using keystrokes. So in this viewer, that again is a piece of Ansys technology, I'm going to use an X to spin this thing around. So it supports X, Y, Z. I'm going to turn off perspective. And I'm interested in looking right down the center of this aisle. Now again, I use my little view manager. I'm in the upper left-hand corner. I want to turn off some surfaces so I can see a little better. So again, I'm going to turn off the rear of the room. That helps sometimes. Maybe the ceiling, not so much. But let's take those block surfaces off. And let's turn off the baffle surfaces. If you end up turning off too much, it's difficult to tell what you're looking at. But that's a beautiful shot right there of what's going on the hot aisle. It's important to look at the hot side in the data center, not so much the cold side, but the hot side. Where is the hot air going? What are the issues? So here we have the air coming out of the servers and up and going into the ceiling plenum. A lot of it is exiting. It's exiting correctly, but a lot of it is also going out and creating a pressure gradient in the hot aisle, because we're venting to atmosphere. Effectively, what's going on here is the servers themselves are the only things moving that air. There's no, and when you have a crack running, it's pulling it because it's connected to the ceiling plenum. But here we're just dumping air into the room and venting the hot air to the atmosphere. And so it's leaking through. I've got the leakage set at 5% on the containment, which you should do. All containment leaks, and you should let it leak a little. And you can see here that it's leaking out into the room, and that is what's causing some of the hot spots that we saw over on these racks, was that effect. So that's really quite a nice image of what's going on in that data center and under these conditions. Now, it may be fine. Let's take a look at our allowable range. In the case of allowable, we in fact are okay, right? Because this is again a conformance plot. So we're looking at, and you can stretch these out. You can also print these. Remember that any one of these, you can use a P key and it will give you a prompt. So I just hit the letter P on my keyboard, and it's going to write this out as a PNG to wherever I want. But for allowable temperature, we're in conformance, so it's okay. It's working in the steady state case. So I wanted to show you that inlets and outlets are handy, even if we're not doing external flow. I was talking to you primarily about external flow because that's kind of why we did the inlet outlet, but also it works really well for general purpose flows, even flows in rooms. So now we can also do room flow. So let me bring over another model here that I have of a simple room, because we've also made it so you don't need to have any cooling units in the room if you don't want. So here's an example that I made of just a conference room. And I made the little people here out of blocks, and I actually used PDUs or HDUs in this case. We have, by the way, generalized the PDU structure. So it used to be, we called it a PDU, and we didn't allow you to set the delta T on it. We had it early on in CoolSim and then took it out. We've added it back in. So you can now set the delta T on these. This becomes very handy for modeling condensers or heat exchangers for air-cooled chillers. We'll get into that in a moment. But you can set these up now with heat load and delta T and flow rate. The flow rate is grayed out because it's derived from the delta T. So as you increase the delta T, the flow will drop and vice versa. Remember that this is, heat transfer is density times mass flow rate times delta T. So, so the heat load will, if you pick the delta T and you pick the heat load, you're going to predict the flow rate based, at least assuming sea level. It will change with altitude, but that's how that works. And all I've done in this model is use that structure to represent the people, because everybody, people are about 100 watts. So I put them in at about 100 watts. And I built one of these and then just cloned it. Again, I can Control-C, Control-V. Once you build a structure in CoolSim, it's very easy to replicate because we have clone. So I built this one. This is a group that's just made up of blocks and HDUs. And then once I have it, so let me ungroup it here first. So once I've created it, and by the way, you can do this in sequence. You can build a person, a little sitting person, and then clone them over to here, and then add the table, make another one over here, etc. And then take this group, clone it over here, take these two groups, clone them over to there. The clone feature is very, very handy because it allows you to take entire assemblies that are grouped and clone them, replicate them. So you can take advantage of symmetry. Now, the way I did these diffusers is I did put them on a block. If they're in the room, you're going to want to put them on a block because it has to either be on a wall or on a block. In this case, I put them on a block, and I have 4 diffusers there, but I angled the flows out of them. This is very typical of a diffuser you'll see in a room when you've got airflow going off in 45-degree directions. I actually have 4 inlets right here. This again is a group. So let me ungroup it. I'll show you how to take this apart. So let me move a block out of the way. And you see I've made 4 independent diffusers right there and angled the flow, and then just set them on the block. Now you need to set them on the block tightly. So we have features like, close gaps to get them onto that surface very tightly. They cannot overhang. They cannot be like this, and they cannot float in the room. You need to attach them to the block, and the outlet or inlet, whatever you're using, needs to be less than or equal to the size of the block. It can't overhang the block. But yeah, that's how you set them up. Very easy to do. And then over here on this one, this is the return grill. So I just set this one to atmosphere. So I just let this one float. Remember, for each of the structures, and if you have trouble getting at, sometimes you want to pick the surface that it's tough because it's hard to pick it to get at the inlet outlet. So just ungroup it. You can hide the block for a moment, just hide it, and then you can get at that structure to edit it. Okay, so hiding is a way to do it. Just remember to show everything before you submit the simulation. Oftentimes I'll get models from users that are failing because they forgot to unhide prior to submitting. And if you hide and submit your model, the hidden objects will not be in the simulation. That is a diagnostic tool we use to find out what's wrong with your model. We'll hide things and see if it runs. But here what I've done is just set it as an outlet. So that means it floats to atmosphere, and then I submitted the model. And what you get back is, of course, same kind of thing. Now, if you group your objects, your inlet outlets into a group, they show up as a group. This is a very handy thing for reporting. So each one of my groups that I have in this model over here are the inlet outlet on a diffuser structure, and they're all reporting together in the output report. It's another feature we added so that you can keep track of things. Otherwise, we'd have a big long list of inlets and outlets and you wouldn't be able to tell where they are or which ones they are. You can name the groups whatever you want, and then they'll report in a structure like this. So here I've got 4 of them. They're all flowing at the same rate, of course. They're all supplying a temperature that I have preset. And then over here, you can do velocity cuts and temperature planes and cuts just like always, just like in a regular data center. But we now have the ability to take a look at just internal flows. You could use this for clean rooms. You could use this for pathogen mitigation, structure or studies where you're looking at air change rates, and we also have, of course, path lines. So down here in the lower left, we have 2 new plots. Let's take a look at them by velocity. We can look at them by temperature or velocity. This is a velocity plot. It's kind of busy. It shows you the path lines in that room. You can see the room is fairly well mixed. I've got the air change rate turned up pretty high here, but you can see also there are periods in that room where there's no flow. So there's a dead zone right there caused by those diffusers. You can see the flow actually angles to the return over here. So the flow is, and there's kind of a dead spot right there in the middle of the room, which doesn't surprise us because there's no diffusers there. So, if you're in this room and there's filters in this return and you don't want to get sick, you want to sit near the diffusers. But this kind of capability is now available in CoolSim. I mean, this is not a data center at all, but the fact that we've introduced inlets and outlets allows you to begin to look at these things, look at general flows. We get dragged into a lot of different kinds of modeling as a consulting practice, so we're always modeling interior flows of some kind, ranging from gun ranges to operating system environments. I do have another one here that is an OR that I'll show you quickly. This is a model we did recently for a fairly significant hospital in the United States. This is an operating room. So let me back up and show you that this is an OR, okay? And what we've got coming out of the ceiling are inlets. These are laminar downflow units. These are very typical in an OR where you'll have these panels that diffuse air, very straight and laminar flow down through them into the environment. They, in this case, want it, and of course we've got air going out of the walls down low. This is a kind of the proper design for operating rooms where you diffuse out through the wall. You're up off the floor. We also put doors in place and let it leak underneath the door as well. That's an outlet, general outlet. So I'm showing you this. I know my audience here is more data center specific, but, and here we even put the monitors. These are electrical displays of vital statistics. You see the patient laying on the table there and the people surrounding it. I've added a little heat from each of the people using our new HDU structure. So you're able to look at plots now, and I've added some, they wanted in this case to be able to model the obstructions to the flow. So some equipment's in that room. And again, you're able to run and be able to look at flow patterns. So here they're most interested in velocity cuts. They want to make sure the velocity is uniform. You're looking for a uniform velocity in certain directions. It needs to be down. Let's do one in the X plane. They're interested in it about a foot away from the OR. So here, and again, I can use keystrokes to line this up, turn off perspective, and I get a nice view of the velocity profile in that room coming down from the diffusers into the room. And we have it at different locations throughout the room. So CoolSim is becoming a pretty handy tool for doing many different things. This is an example of an operating room. But let's go back now to data centers because that's what we're here for mostly. And I want to talk to you about external flow. So in the external flow case, we have the ability to set wind speed and direction and build generators. A couple things I want to show you there. Let's first do the wind speed. So I'm going to bring up this simple model. This is one generator. You notice now I've set the room to be very big. The room becomes the outside. The room becomes effectively what we've called in the past the bounding box. So it is the domain of the airflow. You want to make sure it's big enough so that the air settles out nicely in this direction. There's an outlet over here. This is the outlet to atmosphere in this case. This is the air coming in. So it's moving in our case left to right. In the room editor, what we have called the room editor in the past, we now have a new feature called external flow setting. And we did this very intentionally. We try to set this up to be easy to use. Again, this is often done using unit vectors. We're not using unit vectors here. We're just using a compass and a wind direction indicator. So when you lay out your room, you put your structure in place and it's set like this, and you think, well, north is to the top. Well, that may not be the case. There may be an angle on this. North may be over in this direction somewhere and not straight up. So what we've given you is the ability to do a offset, and that's right here in the flow setting. You can offset the direction of north. So this little compass will move around for you and allow you to orient the compass, not the object in the room, but the compass, so that you can have north. So now our north is off to the right. So north might be over here. And then you can set your wind direction based on the compass. So wind direction here could be, to the southeast direction, or it can be wherever you want. And you can set your velocity and your temperature. So that's just really handy. That's a nice way to do it. We've given you a little structure here, a little X, Y, X, Z. Remember that in CoolSim, X is to the right, Z is to the bottom, Y is straight up out of the page. So that's how it works. In CoolSim, it's a right-hand coordinate system with the Y axis going up. And by the way, just to remind you, the origin is in the upper left-hand corner. So you can set your flow up that way and then run the model. Now here, what I've built for you is a little generator. Generators are, the way you make them is essentially as a box. They're just blocks, and then you put inlets and outlets on it. So this particular structure of a generator has air coming in through the back here, through a heat exchanger, passes over the motor, which sits in a box. This is a diesel motor, diesel generator. And then it has a heat exchanger on the front that dumps the temperature of the water jacket. So the generator, if you remember, has a water jacket, dumps that heat. And then the most important is the exhaust that comes shooting out of the pipes. So this is two banks. It's probably V12 kind of structure, and it's got two banks of cylinders and outlets. Now, what I've done here is just put inlets and outlets to represent those flow conditions. I don't really care about the delta T in it. I don't really care about much about that structure, about that generator, except its heat coming out. I'm interested in particularly these exhausts and their flow magnitudes. So what I recommend is, if you want to build one of these structures, do it by itself first. Just set it out by itself, build the blocks, get it to run, get it to work. The trick here is making sure that your inlets and outlets are on a surface. You've got to have them touching the surface. So this entire thing is grouped at the moment. So I'm going to ungroup all. I'm going to show you how I built it. So here is a structure. This is also grouped. You can have different levels of grouping. I'm going to hide this block just so I can show you the inlet outlet. That's the easiest way to get at it sometimes, because when they're coplanar, it's hard to pick it. So I'm just going to take a look at this structure. This is a little outlet. It's a certain size, and there's airflow here. I'm operating this one at 4,800 CFM and 900 degrees Fahrenheit. That's a spec that I got from the cut sheet on the generator. So it's easy enough to build these. All you do is look at the specifications on the generator itself, get the dimensions of the structure, and then they will typically also list the exhaust magnitude, mass flow rate, and also the temperature. So I just created an outlet there at that temperature and that flow rate and stuck it on the end of a block. Same thing down here. I was able to pick that one in that case. So I don't have to hide the block. If you have trouble, just hide the block and then pick it. Over here I have airflow. This one it's much bigger. The airflow is bigger because it's a bigger surface, but the temperatures are lower. And these are generally set to normal. Now on the back side, I've got air going in, right? Because this one is sucking air in. So we'll take a look at this one. Again, it's a little hard to pick that surface, so hiding the block is the easiest thing to do. And here, if I spin this around, you can see that vector is pointing in. So, but I've set this one to be a specific velocity and a specific, range. So, same as the outlet. They don't have to be the same, by the way. In CoolSim, you can set the inlet and outlet to be different. But in this case, I've set them the same, and the incoming temperature in this case is 104. It doesn't really matter because it's coming in. And then I show all. Make sure you show all to put those blocks back in place. And now I can group that, and I can do things like clone it, and I can replicate it. So if I group it, now I can export it. So I can write it out into a directory as generator 1 and use it later, or use it in another model. And I can also clone it. I can Control-C, Control-V, but cloning works really well because it gives you exact offsets. So in this case, I want to offset it, let's say 16 feet in the Z direction. And I, in this case, just want one copy. And I apply that, and it just replicates it. And you can replicate in all 3 dimensions. So once you've built one and you get it working, it's really easy to replicate and to just use it somewhere else. So I tend to build them separately by themselves and then read them into a model that I'm interested in using them in. So I have just a directory. I don't really use the library system in CoolSim. I don't know why. You can, it works fine. You can save this off as a library object if you want and put it into the local library system in CoolSim, but that makes it live only in your version of CoolSim on your machine. What I tend to do is write them out to a directory. That way I can share them with other people if I want to. So I do a lot of sharing with you as users, so I can export it out and just write it out as a CSO file and hand it to you. These are very small. They're kbytes. I can attach it to an email and pass it over, and you can read it in using file import object, and you can read it right back in. So that works quite well. And then you can run it to see if it works. Now I have run this one to make sure it works. I've put a prevailing wind on it, and we can go over here and take a look at external inlets by, let's take a look at them by temperature. And the inlets in the room will show flow. So here I've got the wind blowing pretty hard from one direction just to make sure it's working. And you can see there that the air is coming out of the front of the radiator. I call them a radiator, they're a heat exchanger. The big heat exchanger is down here, air is coming out, but the bigger, most important one is this one. The wind's blowing straight at it, and what you need to worry about in most cases is as this plume comes out, is it going to interfere with structures behind it, most notably other structures to the left or right, like condensers, or other elements like air-cooled chillers. You see buoyancy working. There's the buoyancy effect of temperature that's causing that to go up. So buoyancy, of course, is turned on always in CoolSim. And so you can build from something like this, you can build structures that look more like this. This one is quite significant here. Now, again, we've done a very similar thing. We've built these generators. These happen to be exiting at the top. So if if you look closely, you can see the little arrow pointing straight up, and their intakes are on the back side. So there's sides to this one, and then the chimney sits at the top. This one is sitting in and sometimes they're called data yards. I don't know what they're called internationally. They can be many things, but here we have heat exchangers over here. These are condensers, typically, and then we have the generators sitting in between them. Not an unusual situation, but the problem is these generators, condensers, behave in a way that is such that if the inlets get too high, the cooling capacity of them drops off very quickly. Now, let me just show you how I structured these as well. I'm going to hide this fence that sits around the outside, and I'm going to show you how to make these. This is, again, a group. So again, you make one of them and then clone it. So I'm going to ungroup it so I can show it to you, and I'm going to hide this edge. This is a baffle. We use baffles. These aren't leaking, or actually these do leak because air has to come in underneath them. But again, it's just what we call an HDU now. Okay, so it's just an inlet outlet pair, just like a heat exchanger, and it's dumping heat. It is also grouped. You can have a nested group. So I'm going to ungroup this one. I'm going to show you just one. So let's take a look at one of them. You see it's got specifications. It happens to be a Liebert. It's dumping 31 kilowatts. It has a delta T of 11, and that makes the flow rate about 4,800. And what we're concerned about is the inlet temperature of these devices. So you set this up. Once you've built one, as I mentioned, you just clone it or replicate it and align it. You can align groups as well. So, you know, the align feature works on grouping. So I can align a group, align it to X or min. So X min or X max or Y. Let me show you that again. So control key, put your cursor over the one you want to hold constant, align to X min, X max. So you want these things lined up tight. Always the case in CFD, you want good alignment so that the mesh doesn't create unnecessary cells that might have trouble converging. So we have this very nice closed gaps, aligned fronts feature, and it works on groups as well. So, yep, and put those in. Now, you go ahead and set the airflow just like we did before. So in this case, we're setting up airflow on this domain. This is a very large domain. That's a large building, but it runs in a reasonable amount of time. It takes about an hour for that to run, and then we can go in and take a look at, again, let's take a look at path lines by temperature and see what's going on there. So this is the air coming from one side. It looks like we're blowing from the left. No, it's running at an angle in this case. But you see what's going on here is that, and again, we can use this feature where we allow you to turn off surfaces. So let's turn off the baffle surface. No, let's turn off the block so that we can see, and you can see the problem right there. Air is getting from the exhaust of this device, it's coming down and being sucked into these intakes. You can see it a little bit better if I maybe turn off, no, not that one. You can just experiment here. Floor surface, yeah, it's probably the best shot. Baffle surface, there we go. And again, you can set it up so that you can use your X, Y, Z keys to align it. There's my Z key. You can come in tight on that shot, and that's a pretty good representation of what's going on right there. We've added one more plot to this sequence for external flow, and it's the HDU temperature inlets. Because as I mentioned, inlets are important for these structures. So I have set it up so that you can take a look at the HDU inlet temps. And this one takes a little longer to load because there's an awful lot of them. So you need to be sensitive to that. But let's take a look, and you want to zoom in on it. So let's go for a Y command, and we'll turn off perspective, and we're going to zoom in and take a look at those inlets. Let me blow this thing up for you. There's our problem. I mentioned this in the earlier shot. I could see path lines coming into these. These are getting contaminated. The inlet temps on the heat exchangers over in this range are quite high. They're probably recirculating on themselves as well due to the pressure gradient caused by the Bernoulli effect, the wind. And so I've got problems right here in this design. So right away we say, okay, what can we do to affect that? Can we move them over here? Would it help? And you begin to play what if scenarios. We also have traditional path lines from racks and PDUs, of course, and so we do separate them, the inlets and outlets and the PDUs, but here again, we're seeing contamination from one to the other. Let me show you this one. So again, let's go to Z. I'm going to turn off perspective by using the N key. I'm going to zoom in tight with my mouse here and then use this little viewer to do things like shut off the blocks so I can see. I'm going to shut off the baffle surface so I can see, and you right there can see it. So the air is coming out of this one. The wind's blowing from the left to the right. It's being sucked into the intakes of this one. This one is contaminating the others. We've got a downstream effect going on here. It's not good. So this helps you to perform what-if studies on exterior flows, and it's quite effective and will give you a lot of help in these kinds of cases. All right, so we're running a little long here because I got started late, but there's a couple more things I want to review with you. I've already shown you the capability of setting up the model and the exterior flow. I showed you the HDUs and how that's a little different. We now have delta T on those. I showed you how to build a heat exchanger inside of a generator with also its combustion exhaust. These are just inlets over here. You set them as I showed you, and outlets over here. Set up the block, group it, save it as a group, export it out is what I would do to a directory. Set up a directory on your local machine that has the objects in it. It's very handy. I use it a lot. I go read them in. It's just something I've gotten used to doing. It works quite well, and now I can share them, of course, with you. But one of the other features of CoolSim that I really want to get to is a sharing of information. So here I've got some hyperlinks in place, and I'm pointing at a specific URL. This is something that we now support in CoolSim, is the posting of results. Let me show you how that works. You can share the results through hyperlink, and you can do a presentation like the one I'm showing you here and share them via hyperlink. So it allows for the viewing of models without the need for installing specialized viewers. As many of you know, there's many viewers out there. You can view a DWG file using a special viewer, and you can view this with a special viewer and that. But those special viewers require installation. The problem with installation is you often need admin rights to be able to install, and that takes time, and you have to go get an IT person. This feature allows you to share it without that. It's just a hyperlink. So what I've done in this PowerPoint presentation is I've put in an image and I've buried a hyperlink behind it. So I right here, select image to view in 3D. And I could just click on that and it opens on my other display that I'll drag over here, a full representation of that output. So here's the 3D view of that image that I just was looking at. And this is extremely nice, and you can share this with anyone. Now, this is a stacked generators in this case. We're looking at air coming out of the top. You see here we've stacked them. So again, I built one, and then I cloned it to get multiple in this direction. Then I took this set and grouped it and cloned it to get the next set up. So laying out this set was really quite quick, because once you've built one, you can replicate it in one direction, then group that, replicate it in the next direction twice, and you've built this entire structure just really fast. Here on the roof, we've got these heat exchangers sitting up here. These are indicating they're chillers of some kind or air-cooled chillers. We're worried about inlet temperatures again. We're worried about this plume of hot interfering with the units on top of this roof. And do we need to put a fence here? Or if so, how big and how much permeability, that sort of thing. So the sharing is a very, very, very nice thing. And I can also take this PowerPoint right here and save it off as a PDF. So let me just do a save as here to my desktop. I'm going to put it on my desktop. I'm going to write it out instead of a PPT. I'm going to write it out as a PDF. So I'm just writing this out. So I'm saving this all off as a PDF. Now you can use Word to do this. You can use PowerPoint to do this. You can use anything you like. But here's the PDF, right? So now I'm using Adobe to view this. And when I get to that image and I want to share it, I can simply see if it works. It'll pop the same window. So you can share it. I've been having trouble with my Adobe there, but let me show you another one in Word. You can do it in Word, and as long as you don't open it with Adobe, in my case, it'll open that image. So you can save it off as a PDF. The PDF is very small and can be shared with anyone. Here is that same structure that we were looking at before as a model, and you see the 3 files here, same as before. We can look at a variety of things and share them. One of the ones that's most important is the temperature inlets of those HDUs that are sitting on the roof, and this takes a minute to load. In the meantime, I'm able to go back to my PowerPoint presentation. I have these windows open, so here's one of my view windows. Let's see if I can get one that these are all local. So let me grab one here that is from the PowerPoint itself. So I'll put this back in PowerPoint mode here and go down to that hyperlink. So here's the hyperlink that I was showing you. You can tell I'm pointing right at, in this case, the Amazon cluster. So I'm going to copy this and I'm going to paste it into the chat box. Let's see if I can find the chat box here on our GoToMeeting. Here's chat down here. So in the chat box, I am pasting the hyperlink, and you should be able to click on that hyperlink as a viewer and open this model in 3D. Now that same hyperlink you could save as a bookmark. You could save on your own browser, and then you could insert it behind an image and put it into a PDF or a PowerPoint or anything else. And when the viewer is viewing it and they click on that hyperlink, it'll open this image. So it is a way for us now to, for example, use Word to create small documents, small thumbnails, but not give up the big view. One of the reasons that we've always used PowerPoint, as an example, is that we want to be able to see the image. We want to be able to get close and see it. But we've never been able to share the results in 3D without using a viewer. This solves that problem. So you could now create a Word document, put in a small thumbnail, underneath the thumbnail say select image to view in 3D, behind the image paste with a link, this hyperlink like the one I just showed you, and then you'll be set to go. Now the way that works in CoolSim is that when you're running your mail, I'm going to bring up my mailer here just to illustrate this. You get a set of output that is specific to the run you just made. So let me show you this. So I have a special bucket here that I've made called RSF notifications. And I've created a rule in my Outlook that says if an email comes back from this sender, this is CoolSim RSF, remote simulation facility. If an email comes back from this sender, then put it into a special directory on my mailer. I'm using Outlook here. So here, one of the things we send back to you when requested is a link. Now, this one's a little long because it's been through my filter, so a little longer than the one you would have, but you can still just click on that hyperlink and it will open the entire output report. And in that output report, you can have all of these images. You can share the entire output report. I don't know exactly what this one is. Oh, this one was my. Okay, so I can share this output report with you. So I can copy this entire output report, paste it into the chat box, and send it to you. I have just shared with the entire audience here that entire output report. Furthermore, I can do individual images. So if I'm really interested in this image, which is the path lines of output, I can take this image and just copy it and paste it. Now, to get this to work, you do have to request it. So let me show you how to request it. When you go to do a CoolSim run, and I'll grab any CoolSim system here. So here's a CoolSim, this model. When you go to do a run, you want to select results available by hyperlink. So let's say that I like this model, but I wanted to put a new cut plane in place because the current cut plane I have is in the wrong location. So it could be Z equal 20. Temperature at Z equal 20 is not where I want it. In fact, I don't want it there. It's not doing me any good right there because it's not. I really want it through the hot aisle. So let's say I want to change that. So we've got a feature in CoolSim, as you're probably aware, that is plot setup. What you can do is you can go here and you can say, I want to modify post, and I want to add a temperature plot, temperature contour. Now, the first thing you have to decide is where do I want it? We've allowed you to make this interactive so you can see where you want it. And you see I'm lining up here I want it in the Z plane. So here's my XYZ. You see it rotates with my model down in the lower left-hand corner. And you can see I want to be on the Z plane. Question is where? So what we've done in CoolSim, we've allowed you to identify it by just moving your cursor. And you'll see down here in the lower section of the modeler, it records where your cursor is in 3 space. So I want to slice right through here. So it looks like that's right around 12 feet. So if I look down here, I'm making your eyes go down to the bottom of my display. You can see that it will track where that cursor is. So I want it to be Z equal 12. So now I go add me a Z plane, add it at 12 feet. Okay. Now what I'm able to do is run post only. This is a feature we added some time back. You don't have to do the whole solve over. You can just do post only as long as it's been run in a reasonable amount of time. We do delete the results on the cluster after 5 days. So be aware of that. So you shouldn't have to rerun as long as you're working on the model within the same time period. So here I'm going to just rerun post. You want post only. I also want results available by hyperlink. So this is a flag. You need to set it to get that hyperlink to come to you, and it will come to your email address. So now I submit the job. And it says to you, do you wish to redirect the entire solution? No. The model has not been run before in this case. Okay, so in this case, it's going to run the whole model because it has been run before. But typically, if it has been run, you can say, go ahead and just rerun post. So I don't know why that one, I thought I had run that one earlier. Let's try another one over here. Yeah, we don't want to run post on that, it's too big, but that's the idea. Let's try another one over here. I want post to run fairly quickly for you. So I'm trying to find a model here that, yeah, let's rerun post on this one. This will run fairly quickly. Post doesn't take much time to run, but we're running out of time here. So I want to run it fairly quickly. And anyway, that's the sequence. I guess I'm not going to have time here. I'm running pretty far over. I'm 15 minutes over because we started late. But let me just stop and see if there are any questions at this point. I'll start to wrap up. So we've added external flow capability to the tool, but we've also done a whole lot more than that. It's going to help you for internal data center design. It's going to also help you extensively for external flow analysis. You can put internal diffusers on walls. You can create structures. You can create unique structures with inlets and outlets. You can do all kinds of unique assemblies with inlets and outlets and set them all to whatever condition you want. If you group them, it'll also report out as a group into the summary report. Furthermore, we've also allowed you to share results via hyperlink when you choose to do it. It's normally set to off, but if you want to create the ability to share, just flip the switch during post, during the sequence of running your job, and you can share the output. Now, what I'd like to do is ask if there are any questions at this point. I haven't seen any questions come in yet, except one from Jose who said, "You're not sharing your screen," so thank you for that. But let me just ask if there are any questions at this point. I know we're running quite a bit over, and I'll have other webinars as well coming up where I review more of these features and applying to cases. Let me point out that if you do have a case that you have that is unique and you want me to review it, please pass it over to us. We're at support@coolsimsoftware.com, or you can get to me through paul.bemis@coolsimsoftware.com, and we'll take a look at it. So I think I'm going to end it right there for purposes of time. I'd like to thank you all for coming, for being here. And if you have any questions, you want to reach out to me, please go ahead, and we'll be available and try to be responsive to you. Thank you very much, everyone. Have a good day.